You think light travels in straight lines, not mostly straight. Straight, you imagine space as a clean, invisible stage, empty, neutral. Light crosses it like a laser pointer across a room, and gravity in your head is a pull, a force that reaches out and grabs things with mass. So here's the picture you carry without noticing. Gravity pulls rocks. Light is not a rock, so light should not care. But the universe does something quietly humiliating to that belief, because out there, light curves, not because it chooses to, not because it slows down and falls like a thrown ball. It curves as if the straight line you trust isn't straight, and that should bother you more than it does. Because if the straight path of light can bend, then your mental map is wrong at a deeper level, not the details, the foundation. It means one of two things must be true. Either gravity reaches into light and pulls it like a hand on a string, which breaks the clean separation you assume between mass and massless. Or the idea of straight through empty space is the mistake. The stage isn't neutral. The emptiness isn't empty in the way you imagine. And here's the uncomfortable part. You probably still picture Newton as the person who would reject this. Newton, forces, arrows, attraction, certainty. Newton, the last man, who would say light bends. So when you hear the truth Newton uncovered, you imagine a contradiction, a modern correction, a later genius fixing an old mistake. But that's your bias toward neat timelines, because the real problem isn't whether light bends. The real problem is what bending even means, when straight was supposed to be the simplest idea you had. If straight lines can fail, then your intuition doesn't just need upgrading. It needs replacing. You don't question straight lines. You use them before you think about them. You draw them without asking permission. You assume they exist even when nothing else does. A straight line feels like the most basic promise reality makes to you. If nothing interferes, things go straight. That belief is so quiet you don't notice it shaping everything else. Motion, direction, distance, even truth. Straight means honest. Straight means direct. Straight means real. And light, above all else, is supposed to honor that promise. You imagine a photon leaving a star and cutting through the universe like a needle through fabric. No hesitation, no opinion, no curve. Just forward. This feels so obvious that it doesn't feel like an assumption. It feels like common sense. But common sense is not the same thing as structure. It's just habit. Here is the uncomfortable part. You have never actually seen a straight line. Not in nature, not in space, not even on paper. Every straight line you trust is defined relative to something else. A ruler, a table edge, a coordinate grid you learn to respect in school. Remove those references and straight becomes slippery. Imagine drifting in deep space. No stars, no up or down, no grid. You release an object. What does straight even mean there? You'll say the shortest path. Shortest according to what? Distance already assumes a geometry. Geometry already assumes a structure. And structure is exactly what you haven't justified yet. You thought straight lines were primitive. But they are not. They are conclusions. And physics built an entire worldview on them before admitting that. When you say light bends, you're already smuggling in an assumption. That straight is defined first, and bending is a deviation from it. But what if straightness itself is the thing that fails? What if the universe never promised you straight lines at all? This is where discomfort should start to set in, because gravity bending light isn't strange on its own. What's strange is that you expected light to go straight through nothing, as if nothing had rules, as if emptiness were neutral. As if the universe owed you Euclidean honesty. The moment you realize that straight is not guaranteed, something shifts, not in gravity, in you. Because now the question isn't why light bends. The question is, who told you it was supposed to go straight in the first place? You probably imagine Newton's universe as clean and rigid. Space is a box. Time's a clock. Objects move, forces act. Everything happens inside a silent, unchanging stage. That picture feels so familiar that it's hard to see how strange it is, because Newton himself did not treat space as merely a background. He treated it as something that mattered. He called it absolute space. not a convenience, not a coordinate choice. Absolute, that word should already unsettle you. Absolute space to Newton was not defined by objects. It existed whether anything occupied it or not. It had its own identity, its own structure. Motion was measured against it, not just against other things. This was not modest, it was a claim about reality. And here's the part that quietly cracks the modern caricature of Newton. If space is absolute, then it is not passive. You cannot have a privileged frame of motion without a privileged structure. Something has to decide what counts as rest and what counts as acceleration. Newton knew this. His famous bucket experiment wasn't about water. It was about space pushing back. When the water's surface curved, Newton argued that it wasn't reacting to nearby walls or relative motion. It was reacting to space itself. Space, in his view, could distinguish motion from non-motion. That is not a flat idea. It is an active one. Now here's where the intuition you carry begins to wobble. If space can define motion, if space can participate in dynamics, then space is already more than emptiness. And Newton was deeply uncomfortable with that. Because his other great invention, gravity, made the problem worse. Gravity acted across empty space, instantly, without contact, no mechanism, no medium, no explanation he was satisfied with. He called it action at a distance, and he hated it. Not philosophically, physically, because it meant space was doing something he could not describe. He refused to say how gravity worked, not because he didn't care, but because every option implied that space itself was no longer just a container. This is where the modern misunderstanding creeps in. You're taught that Newton imagined forces acting within space, but his own writing suggests something more disturbing. Space was already entangled with what forces meant. He just didn't have the language to go further. So when you assume Newton's universe was flat and force-driven, you're flattening him. You're turning a deep, unresolved tension into a clean diagram. Newton didn't give you a universe where space is irrelevant. He gave you one where space is absolute, influential, and mysterious. And that matters, because once space has structure, once it matters to motion, the idea that light should glide through it untouched is no longer obvious. Not yet wrong, but no longer safe. At this point, the easy explanation is tempting. Gravity bends light because gravity pulls things. Light goes near something massive, it gets pulled. End of story. This feels satisfying because it keeps your intuitions intact. Forces stay forces. Straight lines stay straight until something interferes. Light is just another victim. But this is where the explanation quietly breaks. Because forces, as you understand them, require something very specific, a thing that can accelerate. A rock accelerates, a planet accelerates. Even a thrown ball slowing and falling makes sense. Light does not. Light does not slow down to fall. Light does not speed up to escape. Light does not respond to forces the way objects do. This is not a technical quirk. It's a structural refusal. If gravity were simply pulling on light, like it pulls on a stone, then light's speed would change as it moved through a gravitational field, but it doesn't, not locally, not in the way pulling would demand. So the force picture starts lying to you. You can try to rescue it by saying the direction changes, not the speed. But direction is not something a force can change without acceleration. And acceleration is exactly what light cannot have in the usual sense. This is the first moment where physics doesn't just disagree with intuition, refuses to translate. You're trying to describe something using a language it doesn't speak. So notice what's happening. You are clinging to the idea that bending must be caused by a force, because you don't yet have an alternative picture of motion. Without forces, motion feels ungoverned, chaotic, unacceptable. But the universe is under no obligation to respect your categories. Light follows paths, very strict ones, very precise ones. They just aren't defined by pushes and pulls. And here's the deeper discomfort. If light bends without being forced, then bending is not a response. It's a property of the path itself, which means the path was never straight in the way you thought. This is where many explanations panic and jump ahead. They introduce new words, new theories, new heroes. Resist that impulse. Sit with the failure instead. The force explanation didn't just struggle. It collapsed quietly, not because it was badly applied, but because it was the wrong kind of idea. Light isn't being tugged off a straight line. The line itself is betraying you. And that means the problem is not gravity acting on light. The problem is that motion through space is not what you think it is. You still picture space as a kind of nothing, a gap, a void, a transparent absence where events merely happen. Even after everything so far, that picture lingers, because if space itself is questioned, there's nothing left to stand on. But this is exactly where your intuition has been misleading you. Empty is doing too much work. Space is not a stage waiting to be used. It is part of the script. You only call it empty because it doesn't behave like matter. No weight, no color, no resistance to touch. So you assume it cannot act. That assumption is wrong. Not spectacularly wrong. Subtly wrong. Consider something familiar, a map. A flat map can distort distances without pulling on anything. No force, no push, no resistance. If you walk straight on the map, your path depends entirely on how the surface is drawn. The map doesn't shove you sideways. It quietly decides what straight means. Space does the same thing, not metaphorically, operationally. Once you accept that space can define motion, the idea that it might influence paths without exerting forces stops sounding exotic. It becomes unavoidable. And this is the moment where nothing collapses as a useful concept. Because nothing does not choose paths. Nothing does not privilege directions. Nothing does not distinguish between straight and curved. But space does. That is why calling it empty is a category error. It is not empty, it is unoccupied, and unoccupied is not inactive. This distinction matters more than it seems. If space is structure, then objects moving through it are not moving through nothing. They are navigating a geometry. You don't feel geometry. You infer it from how things move, which is why this was invisible for so long. Light is the perfect probe. It has no mass to confuse the issue. No internal clock to slow. No way to be pushed without contradiction. So when light bends, it exposes the lie cleanly, not that gravity is strange. But that space was never neutral. The universe did not take a flat emptiness and sprinkle gravity into it. The universe shaped the arena first. Only now does the question sharpen into its real form. If space itself defines the paths, things fall. Then what you've been calling bending might be nothing more than obedience. Light isn't misbehaving. It's doing exactly what the structure allows. And that realization quietly removes your last safe intuition about emptiness. You still want an external reference. Some invisible ruler, some cosmic grid, something outside the universe that can tell you with authority what straight really is, but there is no outside. So the universe defines straightness from the inside. This is the part your intuition resists the hardest, because you equate curvature with deviation, with something going wrong, with a path being bent away from how it should go. But that idea only makes sense if straightness exists independently of the world it's drawn in. It doesn't. Here's a thought experiment that removes the last crutch. Imagine two explorers starting side by side at the equator of a perfectly spherical planet. They agree to walk straight ahead, never turning left or right. They keep their direction fixed according to their own motion. No forces push them together. No attraction pulls them inward. They feel nothing unusual. And yet, miles later, they collide. Not because they aimed toward each other, not because something pulled them, but because straight ahead on a curved surface is not parallel forever. Each path was locally straight. Globally, they converged. This is not a trick. It's the definition. Straight lines are local concepts. They only promise honesty in the immediate neighborhood. They make no guarantees at large scales. And the universe operates at large scales. When light passes near a massive object, it is not being dragged off course. It is following the straightest path available. The problem is that the available paths are no longer what you imagine. You expect straight lines to remain straight when extended. But that expectation was inherited from flat space. Remove flatness, and the expectation collapses. So light does not curve relative to space. It curves with space, and that distinction changes everything. There is no hidden force tugging photons sideways. No secret mechanism reaching into light. There is only geometry deciding what counts as forward. This is why earlier explanations felt strained. They were trying to preserve an intuition that no longer applies. You wanted gravity to act, but gravity doesn't need to act if the path itself already knows where to go. This is the moment where bending stops being dramatic. It becomes boring, inevitable. Once straight lines are allowed to curve without apology, light has no choice but to fall. And now you're forced to admit something uncomfortable. The universe never violated its rules. It violated your expectations. Once you stop insisting on forces, something strange happens. The universe starts behaving with unsettling consistency. Stars duplicate themselves. Galaxies stretch into arcs. Entire clusters smear the background sky into rings and crescents. Not because anything dramatic occurred. Not because light was deflected by violence. But because straight paths were quietly redirected long before the light ever arrived. This is what people call gravitational lensing, but that name already misleads you. Lens suggests intervention. An object doing something active. That's not what's happening. Nothing grabs the light. Nothing bends it in mid-flight. By the time the light reaches you, the damage was already done, if damage even the right word. The light simply followed the geometry it was given. This is where consequence replaces abstraction. Because once space defines straightness, massive objects don't need to act like bullies. They don't push. They don't pull. They reshape the neighborhood. And everything passing through that neighborhood inherits the rules. Imagine shouting across a canyon. Your voice curves, not because the air forces it to turn, but because the environment shapes how sound propagates. Now remove the canyon, remove the air. Remove even the analogy. What remains is this: massive objects change what? Paths exist nearby. Light doesn't care what caused the change. It just takes the best route available. This is why lensing scales so smoothly. Tiny masses bend light barely at all. Galaxies bend it noticeably. Clusters turn the universe into a funhouse mirror. No thresholds, no switches, just geometry accumulating consequences. And here's the quietest, most unsettling part. You don't need to see the mass to know it's there. Light reveals distortions caused by things that emit nothing. Objects that cannot be seen directly announce themselves by how they rewrite straightness. The universe confesses its structure through absence. This is not an effect. It's a signature. Once geometry replaces force, the cosmos becomes legible in a new way. Not as objects interacting, but as regions shaping behavior. Light becomes a surveyor, a witness, a test particle tracing the invisible contours of reality. And suddenly, bending stops being exotic. It becomes the most honest thing light can do. It's tempting to end this story by naming a victor, to say that Newton was wrong, and someone else came along and fixed it, to imagine a clean handoff from old ideas to new ones. But that instinct misses what actually happened. Newton did not misunderstand gravity. He uncovered a wound. He showed that motion could not be explained without reference to space itself. And then he stopped. Not because the problem was solved, but because it had become too deep to phrase. His universe was already unstable. Absolute space was not a backdrop. It was a confession that something invisible governed motion. Gravity acting across emptiness was not a mechanism. It was an admission of ignorance. Newton didn't give you answers about why light bends. He gave you the reason the question could not be avoided. Centuries later, when light was finally observed curving across the cosmos, it didn't overturn Newton's world. It completed its tension, because the bending of light is not a correction to physics. It is a correction to intuition. It tells you that straightness is not sacred. That emptiness is not inert. That motion does not need force to be guided. And once you accept that, the universe stops looking like a machine and starts looking like a landscape, not one you move through, one that decides how movement is possible at all. This is where explanation runs out, not because we know everything, but because we've reached the edge of what language can comfortably hold. We can calculate paths, we can predict distortion, we can trace light back to sources that no longer exist. But we cannot step outside the geometry to check it against something truer. There is no ruler beyond the universe. Light bends because straightness is local. Gravity exists because geometry exists, and space is not the absence of things, but the condition that makes things meaningful. Newton stands here not as a man who failed, but as the first to realize that motion answers to something deeper than force. At the edge of light, his shadow remains, not pointing toward certainty, but toward a universe where even the simplest ideas must be earned. And once you see that, you don't just understand why light bends. You understand why the universe was never obligated to go straight.